about. Like
Fantastic.
diesel tests, as in how you test the diesel, the paste that you use to test for water in the diesel, and how you can manage your diesel against thefts. And it was quite interesting. I got to see so many things that I really thought I knew before, but I got to see them, how you manage your diesel suppliers, asking for DPR kegs when they come to do the delivery. And it was emphasized that you use that you ask them not to use their own meter, that they are going to do the supply for you. You insist on the DPR keg for the supply, and how you can manage them and everything. It was quite interesting and eye-opening. Thank you, sir.
Thank you. Fantastic. That was good. All right, who's going next? Takeaways from Saturday's field trip.
Okay. Good afternoon, sir. Good afternoon, everyone.
Good afternoon, Roland. Yeah.
Okay, my takeaway from Saturday trip, though I missed the plumbing class, and the generator and the diesel class was quite interesting, and it made us to understand that the piping, the hose calibrate. Okay, when we now measuring our tank or seeing how far and how much diesel we use, it made us to understand that the hose usually, just like we have in our own facility here, that hose we put to measure that is not the best form to know our diesel usage. That the best form is to actually calibrate like a rod and use that's the best way to get the actual
okay. Instead of using the sight hose, sighting glass or hose, you use a dipstick.
Yes, dipstick. Thank you.
Okay.
So I think that's pretty much, at least I gained a lot that day.
And you understand why these methods are also going to give you variations. Tanks expand and contract during different times of the day. And as they get older, they slack and become more relaxed. So you also need to do a recalibration regularly. Many of us have tanks that have been calibrated since 2010. And that's what we're seeing.
And he also made mention of us washing our diesel tank every 6 months, if possible.
Yes, I mean, we recommend 6 months if you can, but if not, at least annually, have a annual turnaround for your diesel tanks. Because no matter how much you've tested and checked, there will always be residue inside your tank that needs to be cleared out. Because if they mistakenly get through your system into your generators, you smile a different kind of smile. Going to the bank to spend money you don't need to. Thank you for that. Who else? Any lady in the house that was there on Saturday?
I was there. Good evening, sir.
Good evening, Jimmy. Thank God. Go ahead.
I'm just joining. I just tell any lady there that I was there on Saturday. That's
yes, I wanted to give us a takeaway. Your takeaway from that Saturday's outing.
My main takeaway was
muted.
Management of generator, taking supply of diesel, the different ways one can be cheated, maintaining diesel, washing the tank every 6 months, and then the calibration of the tank using dipstick, and I learned dipstick is usually the best way to be sure one is calibrating the supplier's tank, the content of the supplier's tank compared to what it will be at the end of the supply. What else?
Okay, that's fair. That's fair enough. Just a point to note though, all of those site measurement holes and dipstick with metal tanks that expand and contract and slack over time, with all the recalibration we do regularly, still wouldn't give us accurate measurements. Nowadays, with the price of diesel, if you have a 20,000, 30,000 liter tank, and you have the slightest inaccuracy, even 50 to 100 liters right now of inaccuracy is a lot of money. I mean, thinking about the kind of prices we pay for diesel today. So what we normally recommend is try and have a digital generator and diesel monitoring system. Max-Migold installs a set of unique systems that helps you track continuous flow into and out of your tanks. So even if your diesel tank is releasing diesel and the generator is not on at any particular time, there must be a reason why somebody has opened a tap to take out diesel from your tank, for example. You will know real time. And if you have multiple generators across the country, you can see all of them in a dashboard view where you can see all the generators that are on at any particular time. So when you see all those logs that a gen has been put on this time and put off this time, right? Those manual ones, everything we do manually will not give us the kind of accuracy we're looking for. You can have the real digital one that when the gen is on, it logs itself. When the gen is off, it logs itself. So you have accuracy, and you can time generator use with diesel consumption. And the beauty of that system, again, that we deliver is that it can also give you predictive analytics data about your gen, how hot, the oil levels, the battery voltage, the generator rotation per minute, the kilowatts coming out of it, a lot of data that comes out of the generator that helps you to know the health of the gen remotely right on your devices, and they don't cost much to install. So I would advise you to move a step up on the technology ladder by deploying such technology instead of just depending on the manual, go over the tank and put a dipstick, which we've still been doing since, I think we've been doing that since 1960. It's high time we moved over to the technology-backed approach. Now you don't need to do too much justification for deploying technology for energy, because everybody has seen that the cost is killing businesses. I mean, some banks are even closing branches so that they can rotate which branch will work. Go to the bank and say, sorry, go to the one on the other side of town. That is the one working today. We can't run all the branches with diesel costs, right? So that's what's going on now. Every business is beginning to shorten just to survive this period. And we are hearing that it's not the worst yet, that we're heading for 1,500 naira per liter. So those of us who are still providing 24 hours power based on diesel generator, let's start rethinking now. Don't think that the debt is going to be paid up and it's going to clear up and the price are going to go down in a hurry. As far as that war in Ukraine is going on, be ready for an increment in diesel costs. And so smart moves needs to start happening. Start rethinking and rewriting your contracts now, so you don't have to struggle with these kind of issues for too long. All right, so thank you so much for those feedback. Questions from anybody, any real situation you want us to discuss quickly before we go to today's class?
Yes, sir. Concerning the last class, I didn't understand so many things. So.
Okay. Go ahead.
So many things. I can't even say so many things. I was actually confused about so many things. The so many things. It's like I'm doing statistics. That's last class. So I don't know if you can just rephrase a bit, sir.
The one on quality, right?
Was it quality? The one we did last was this FM organization. Yeah.
Okay, FM organization. No. There was no statistics in FM organization. The FM organization is just.
That's why I said it's like that's how it looks like to me, sir.
That's what it's just a high level. You know, the thing about this program is all those topics that we're supposed to teach to only very advanced senior people like heads of FM and property in big corporations. We also add it into the FM Mastercraft so you can learn everything, because what we expect to do is to rise to the top as quickly as possible once you're done with this program, right? So that's why we teach you how to set up a team. If you are made the manager today, you're given a large FM team to manage. Are you just going to leave them the way they work or work the way they like? So that class is basically how to organize your team, how to create the right kind of structure, how to write their job descriptions, how to appraise them, how to set up the kind of system that will enable you to be effective. So it may not be, you know, it may not be something that you just immediately understand, you know, until you start getting into more supervisory positions. You start understanding what complications come out of the span of control and the chain of command. If you've ever said something in a meeting as a manager, and you now heard 3 days or 1 week later the shop floor members saying something different as what came from you, you understand how chain of command has affected that communication, reinterpretation and misinterpretation along the way as it was coming down, to the shop floor. Or if you've had a situation where somebody is being stressed out because he has too many people reporting to him, and he has to look at everybody's report, has to look at everybody's appraisal, have to give everybody tasks, you know, have to do all of that. You now realize that it's not becoming too much of a burden. You understand the real weight of the span of control on organizations. And, you know, there's a lot of those things that you begin to learn better and better as you grow, get higher in the hierarchy in facility management. So yes, if you didn't quite grab everything, what I would advise you to do is read through the materials again, pen down a few questions, pen down a few specific questions, and drop them in the platform, right? So that we can discuss and add more flesh to it. Okay.
Yes, sir. Thank you, sir.
So I'm sure you should be able to pen down some questions, and then when you have access to the video, please go through the video.
Yes.
Today's class is not going to be very full because some of you have decided to drive us out of business by not filling your commitments to make payments. You know, when it is due. We have been very, very patient, running towards to the end of classes, and a few class members here are still owing. So that's not very nice. So please let's sit up. If you are still owing, kindly do the transfer now so that Max-Migold can stay in business and give your other people, other generations coming the opportunity of giving you in this program. Okay. Okay. One final thing before I get into the class, we don't have a class governor yet, so I'm going to announce a class governor to your group. I just need to contact a few of you tonight or tomorrow, and then announce a class governor. What I normally do is ask for nominations from you. But what I've seen in this class is that a few of us have already shown some leadership qualities, and we want to present their name to you as class governors to be able to join the governing council of the alumni. We're going to have a governing council of the alumni of the FM diploma organized in a short while before the graduation ceremonies we're having in December, and then we'll want somebody from the class to also be there, and also to represent you in other ways that we have seen from other classes in the past, okay? So I'm going to make the announcement of who, after contacting the appropriate individuals, and then we'll work with them, okay? Yes, any other question? Okay, I hope you see my screen and my audio is good on video. 1 or 2 verbal confirmation will be fine.
Very good, sir.
All right. Today we're taking design build commissioning. In design build commissioning, we're looking at the cycle of development. How does a project come about? How does a building come about? What are the stages it goes through? And as we talk about these stages, our main emphasis will be on the value of the facility managers, membership of that team that builds that whole process that develops and makes buildings available for our use. And we're going to be challenging ourselves to acquire the necessary skills and experience to be able to contribute to every stage of the development cycle, so that we don't end up receiving a facility that has been built where we don't have any inputs, and then we start popping up all kinds of concerns when we have received it. That is, basically fighting fire. That's what most of us currently do. We receive the facility and we start complaining of all kinds of things. Our first inspection is at the handover. That shouldn't be, right? But if you are given a chance to participate in the construction process, what kind of input do you know you need to make? What qualifies you to be able to make that input right now? How will you make sure that such input is sound enough for it to even be taken seriously, right? So that's why we are looking at the building development cycle in the design build commissioning program. So let's start with how the idea of a new facility is brought to bear. It starts with planning, and planning is basically the process of conceiving the idea of a new facility. So depending on the kind of facility it is, whether it's a school, a factory, a warehouse, a hotel, a church, a mosque, office complex, the retail facility, there is usually something that drives the need for that facility. There's usually an opportunity to be taken advantage of, a problem to be solved, right? Just some kind of thoughts, in the minds of the initiator, the investor, or the developer, right? Now, so once that is there, a picture needs to be built around that thought. And that is what we call the brief that comes out of this stage called the planning stage. Whoever is the creator, initiator, developer, investor, owner, puts together a team to say, this is my vision, and I want us to come up with so and so plans that helps us, materialize or actualize that vision. So the major consideration at this stage is, who are the main customers? Who are they going to be the users? So depending on the kind of ideas, the thoughts, the problem to be solved, the need to be met, opportunity to be taken advantage of, then you need to consider who are the the main users. How are we going to meet the need? It's talking about the need of some users, right? Having to take advantage of the opportunity. That means somebody has some money to pay or some problem that needs to be solved. And we can provide this facility to meet that need. That's the whole idea of the planning stage. So you start asking questions like who, what, when, why, how, what can we put in place to ensure that we can take this advantage? Now, in that thinking, you are looking at what kind of functions will exist in that space, what kind of people will use it, how many, what demographics, we're going to serve, and so on and so forth. Then you now move from the customers, potential customers, to the facility itself. What are we building? What kind of facility? How big? How many of this and how many of that? What are the different categories of functionalities that need to be performed there? And how much of each of those functionality will be done that we need to provide spaces, and what services will need to be added to it? All of this is done during the design stage, the planning stage. At that stage, we come out with a brief that goes into the design. This brief is a document that outlines strategic objectives of the owner, key user groups, functional requirements of the facility, dimensions in terms of scope, size, how many square meters, how many sitting space, and so on and so forth. So many considerations are built into that, but it's a very high level strategic document, right? And everything about what kind of location, how much we need to invest, return on investment, financial metrics, a lot of high level thoughts go into the brief. When design teams are brought together, you have the designers, you have the other consulting engineers who are going to be doing additional design work with the main architectural designers. And then they take this brief and they try to interpret it by using 2-dimensional and 3-dimensional drawings and different types of projections to create a virtual reality of this brief, to say for us to meet this requirement, these and these are the kind of spaces we are going to create, and so on and so forth. Now, while doing that, okay, I need to quickly make a note. 1 second, please. So when the design team receives the brief or the strategic document for the facility that is going to be built, they carry out what we call programming. In programming, they use user requirement data gathering, they use observation, they use questionnaire surveys to talk to people who are going to use the facility, at least sample groups, and come up with user requirements, right? It's based on those user requirements, they will now create a spreadsheet of spaces that will be met. So the quantities and quality of those spaces, the services that will go in there, they will capture all of that information, in that programming stage, and then they begin to create design. They create a design in several stages. You start by creating simple schematics drawings that are made up of bubble diagrams, stacking plans. Bubble diagrams are just relationship diagrams. You just draw circles to say, let's say you want to provide for 10 functionalities. And then I create bubbles first to put the functionalities to each other. So how do they relate with each other? And then from there, I can, if I'm going on a high rise, I create a stacking plan. So on level 1, I'll have this department. On level 2, I'll have this and that groups. On level 3, I have that and that, depending on how they work, because it depends on how they relate to each other at the workplace to reduce friction and to improve productivity that I arrange those. So those schematic diagrams will now be translated into single line diagrams as I'm building these spaces up. At that point, the client needs to, and this is where we need to be very conscious. Don't allow design teams, even with all the details done in brief and your participation in programming, don't allow them just go with the brief and the documentation and come back with finalized drawings. So they cannot come back with finalized drawings. Drawings have to progress. The relationship of every part needs to be agreed to. And then once they're done with the schematics, you now give them a sense of dimensions. If there's going to be a kitchen, how big do you want a kitchen, right? You have this kind of space, how big? Because they're going to create those into the single line drawings that helps to put relationship. First of all, they put those positions together or those spaces together in a schematic, and then they add those dimensions to start expanding those spaces. From there, upon your approval and review, then you go on to more fleshing out of the drawings. They now come up with more detailed 2D drawings, sectional plans, 3D dimension drawings, and so on and so forth. And then with the design, they also need to create the bills of quantities and specification document. This is where every material that goes into the final output, where there's going to be wood, what kind of wood, where's going to be metal, what kind of metal, where there's going to be tiles and concrete and all kinds of things, right? Everything is specified, even where there'll be cables and electrical systems, what kind of specification. And the quantities of each go into the bills of quantities. Now with the design and the bills of quantities, you now have enough information to create a contract, right? So the design, the bills of quantities, and the construction contract go out of the design phase into the construction phase. In the construction phase, you're actually trying to materialize that construction into reality. So someone is using construction methods to interpret the drawings, the bills of quantities, the contract specifications, and whatever other information you have in the contract into a real construction. So the project management plan is created out of this, and the schedule, the cost, and all the other risks and all the other plans we talk about during project management are rolled out, and the construction, gets underway. During construction, the drawings that were developed from design that came into construction goes through further evolution, right? So you have a set of blowouts or details, what we call workshop drawings during construction. You also have construction drawings that are reflective of the reality, because when you're designing, everything was still abstract. Now that you're on ground, you're now seeing more details, and you can now begin to make some little changes. All of those changes cannot be made on the head, cannot be made on the ground without going back to make those changes in the construction drawings. So that is done. And when you start going on all those procurement that goes into materials, bringing labor, skilled people to come and work on the project, there will also be need to keep updating the project plan and the bills of quantity. So at the end of construction, you not only have a physical building that has been developed according to the project plan that was laid out at the beginning, but you also have a revised design, which is no longer called design, it's now called as-built drawing. Because throughout the construction process, you were changing, modifying. When you are done with construction, you measure and draw to create your as-built drawing. Your bills of quantities were always being changed with different changes every time during the construction. At the end of it all, you finalize and say this was the final bill of quantities that was built. That's called the as-built bills of quantity. And from the construction too, you've been doing commissioning as things are being delivered. Oh, the concrete systems structures were laid. You do commissioning of that. You do elevators. You do commissioning. You do generator and power systems. You do commissioning. All of those data are compiled. Even if commissioning is not completed at that point, because we're going to get to that phase soon. The data on how this commissioning will be done, the spreadsheets on how testing will be done. For example, every test item has to have a test parameter coming out of the operating parameters to be tested. All of this documentation come out of the construction phase. And then the next phase is to test that things work. Testing is just for functionality. Does the generator work? Does it come on? Does it bring up power? Yes, so if a generator that is 1000 kVA can even power up one flat in the estate, at least it's working, right? What about the temperature of the gen? Is it going out of fan? What about the vibration, the sound level, the emission? You're testing for all of those, right? And you can do that testing based on certain testing guidelines, like your usual lab test you do when you go to the hospital to do a lab test, right? There are parameters on the sheet. There are normal ranges indicated. Those are the operating parameters of your normal body in the building. Every system is listed. The operating parameters for different features or different characteristics of every of those building system is listed. And then the standard ranges are listed. So when you do your test, you put your test result and you put an interpretation. That's what testing is about. Okay, so if you put a wattage range of this to that, when you do a test, using a clamp meter or any of these electrical testing devices, you get a number, you write it down. And then interpretation is it within the range that has been certified for this size of equipment, or is it outside the range for that size of equipment, right? So you are doing testing. Now, once you are done with testing, another thing that you need to get into is what we call commissioning. Commissioning is really not testing. Commissioning is checking for adequacy. While testing checks for functionality, that it works, that it meets its operating parameters, upper and lower specification limits for different engineering parameters. Commissioning is whether it's enough, whether it's adequate, whether it meets the design requirements, right? So you can have an AC working, it's tested okay, and because all the operating parameters are okay, but the AC does not cool based on the activity we perform in this room. You know that when we sit down and take a class in a room, the AC requirement is very much reduced. But if that room is designated for a party, a nightclub, a church service where you're dancing and doing all kinds of stuff, you definitely require additional air conditioning. So it's not enough to say the air conditioning works. That's testing, right? But commissioning is air conditioning or cooling is adequate. People have to be in that space, use it for what they're meant to, and ask, how comfortable are you? Are you sweaty? Are you feeling heat? Are you feeling exhausted? And so on and so forth. That's the whole idea of commissioning. So we can test all systems. We can also commission all systems, from concrete structures to electrical, mechanical, and plumbing systems. And then document what comes out of all of this construction, testing, commissioning process are documents upon documents that go into handover. Many times you will have experienced some funny handover experiences where keys are being passed on as handing over, right? Keys being passed on and not handing over. Even when you see a facility working effectively as designed, the facility itself needs to be documented using all of these document sets that we've talked about. Handover is a handover of both the physical structure that have been delivered as well as all the documentation that make the facility operations effective, seamless. And that's the whole idea of today's lesson. By the time you get into facility management, everything you need to manage that facility is already handed over to you. Everything from all the maintenance procedures in the O&M manuals for everything built in the facility, they are there. Training of your staff who are going to do the facility maintenance from the construction and delivery teams, and training records of all of that are there. All the permits and licenses and documentation that they signed up to, approvals they got from the government and other agencies when they were building, they arrange all of those ones and hand over. The as-built drawings, as-built documentations of everything, all handed over. And the FM comes in, refines, looks through all of that, creates a bespoke maintenance and operations program, creates some strategic facility planning, and can roll on with that facility operations and maintenance until the useful life ends for that facility. So in essence, this entire process needs to be understood by the FM, because the FM is the one going to take over the facility at the end of the day. The FM needs to be conversant with what goes into the entire delivery process so that you know what role to play. And so we're trying to talk about operational readiness. Operational readiness, the seamless approach, the seamless transfer of buildings from construction to full operations, so that you don't have any hiccup in a structured manner to a good program, such that there's no, there's no gap, there's no break in the delivery process. When the FM takes over a property that has gone through this kind of delivery process with operational readiness in mind, operational readiness built into the delivery process from the planning stage, you will find less and less of issues with managing facilities, that goes through this process. So what are the typical stages the facility will go through? You will go through planning, designing. We just talked through all of this process. But what does the FM? What role does the FM play in this whole process? What role does the FM play in this whole process? If you look at what I have here, you will see that in every phase or stage in the delivery process, there is a main driver, and there are other players or key stakeholders in the team that play input roles, right? So during the planning stage, the planners, the owners, the financiers, some people involved in the business case, the business planning and all that, they do that as the driver, planners. Then they get input from construction and the FM team. At the design phase, development process of design stage, the construction team needs to be involved, and the FM as well. During the construction stage, the drivers have changed. It's now the construction team is driving. You have the planning team, the design team, the FM team on ground to have input. And then the construction team runs through the entire process from testing, commissioning, and handover, and then hands over to the FM team. In all of this, you see the FM participating. And then at the time the FM takes it over, at least for the initial 1 year or two, you have the planning, design, and commissioning team involved as people or teams which the FM gets into to drive the operations and maintenance of the facility. So let's get back to this first stage, the planning stage. What role does the FM play? What does the FM do at this stage of planning? right? So that's a very critical question. The FM is supposed to be the person who experienced the owner or initiator experience his customer base, right? There's expectation that the FM knows who we are going to be building for. So when we are creating plans, creating financial analysis, the FM has an idea. So the FM can contribute to relevant information as to how big, for example, what kind of location should we be looking for, and so on and so forth. The FM plays a role with the owner as the owner's representative. This is the point where the FM who has experienced the owner's other property and other customers, or experience in the same industry, other owners and customers or building users in that industry, brings an input to the development process when we are still doing planning. By the time we get to the design phase, requirements have been set. These requirements will include user requirements, construction and engineering requirements, as well as maintenance, maintainability and assets requirements for the facility manager. This is the last one, is the one that is often missing. You see a high rise, they build it all up, all fanciful, and we're launching and happy. And then the FM comes to maintain that space, pushes security guards to stand watch, and there's no toilets, no changing room, no showers for the security guards to change their uniforms when they come to work and when they leave. And you'll be wondering, so, how did we get to this point, right? Of course, the design team worked purely on one-dimensional approach. If the construction guys are not involved during design guys can design all kinds of things, and then you now need to come and build it, and you probably need to set up some cranes here and there, and you cannot have any room to maneuver your cranes to build the facility, right? So the construction team needs to be part of that process. There are certain things that cannot be built in certain locations, for example, because of soil type, because of climatic conditions, because of urban flow, traffic flow, and the rest. So the construction team needs to be part of that process as giving input, just the way the FM team is giving input. The FM concern here is, one, taking as much as possible with the original intent, so that you don't come during design and start changing what was originally intended. Two, the FM needs to give advice on maintainability issue, things like access. Where should we have manholes and chambers so that we can do inspections when things start getting old? What kind of materials should we use? What materials actually give us less headache over time? What kind of work methods give us less headache over time? Because you've experienced degradation curve, and you have seen facilities run from 1 year to 20, 30 years, and you have been part of inspecting and different ages of facilities due to different materials and work methods. It will be easy for you to make some little inputs here and there about materials, about work method, about the proper documentation that should go into operations and maintenance, so that from design stage, you're not leaving any gap that will become an obstacle to the operations and maintenance process. So in essence, the FM contributes to design, so that at the end of the day, when the design is finalized, the FM knows that it can manage, it can maintain. The cost of managing and maintaining and operating will be least, because at this stage, you know that we have a huge operations and maintenance cost compared to construction costs. But the guys who are doing construction at design stage, they want to deliver that project at the cheapest, at the quickest, right? They don't have so much concern about operational readiness, about long-term maintainability and sustainability issues that the FM will come to deal with. That's why he needs to have those inputs. He needs to be representing sustainability and maintainability at the design stage, so he can help to into the development process. And then at the construction stage, all kinds of variations are popping up. People just want to do things as conveniently as possible, so that they can meet with the schedule and meet with the cost that have been earmarked in total. But the FM needs to also watch for objectives, make sure that the client's objectives, the user requirements are not sacrificed on the altar of convenience for those who are delivering. Also ensure that all variations are minimized as much as possible, and that the change management process for variation implementation is strictly followed, as well as the documentation of those variations, so that, and those changes, because at the end of the day, the FM needs a proper documentation of what is, not just what was intended. So the FM plays a role there. And then when there are instances of construction defects, snags, things not built to specification, the FM also needs to play a role in checking those kinds of excesses and make sure that whatever gets approved is documented so that the operations and maintenance has the right information to take decisions as they go. And then getting into the testing and commissioning phases, just ensure that the right templates are extracted from the design engineer's specification documents. So they provide specification documents that the bill of quantities were developed based on. That's the QS. Quantity surveyors use the specification document from the engineering consultant to develop the bill of quantities, right? Now, those specification documents already include certain operating parameters for the different requirements for different materials, equipment, and structures that are going to be built. The FM ensures that the testing engineers or the commissioning engineers are able to extract the appropriate testing parameters and ensure that it witnesses the testing process so that the right testing tools and kits are used and the right results are documented. And a proper interpretation of those results, you know whether there are additional defects instead of just looking the other way while standard numbers are written into test results, and you have to come and live with it eventually. Commissioning can be done possibly during delivery. It's possible to have enough load, enough user data to say this equipment or this asset commissioned okay. But in many cases, we have to do continuous commissioning where we continue to gather data because the building is being ramped up gradually. People are coming in and it's increasing, right? So we have that continuous data gathering for commissioning data satisfaction. And then once in a while, we do a holistic review, we do a condition assessment, or we do a major upgrade, and then we come, or we even have a change in facility mission or use of that space, and then we need to do a new commissioning called retro commissioning. In essence, checking for adequacy means observing user behavior, documenting convenience, doing a post-occupancy survey, for example, is one way we do this, and gathering data on how users are using the facility and how the facility is meeting the needs of users. This is basically something that the FM needs to contribute into, because what the construction guys can do is mostly simulate adequacy, simulate commissioning conditions. For example, they can use a load bank to check for a generator's condition for commissioning. If they don't have enough load in the facility, they can bring a load bank, introduce into it that applies resistance on the generator, and the generator is able to work in a way that it brings about what is intended for, what it was originally designed for. So in essence, the commissioning process on the data, the FM makes a lot of input into that process. And then you have the handover, which is documentation, like we keep saying, and then the FM receives all of this data and all of those documents that go into the... All right, so let's look at some of the things I've been talking about. At the design stage, what's the FM's role? Review owner's project requirements and basis of design documentation. For clarity and completeness, it needs to be built because you are going to be the one to manage it. It's like I have to fully understand what is going to be delivered. Monitor commissioning team, which includes quality assurance staff of main contractor and project consultants, and hold a pre-mobilization meeting. You participate in the commissioning process. The commissioning process will start from the beginning, where they continually look at the user requirements through the design to the construction and ensure that all of those requirements are being carefully captured. Participate in quality management and commissioning meetings, perform focus reviews of the design, drawings, and specifications at various stages. You can imagine. So the FM needs to gain some confidence in being able to understand what a drawing is saying. So that's something that we need to also pay attention to. Those are some of the areas where you need to study and continually improve yourself so that you can become good enough to make this kind of input when the opportunity arises. Assist and review the development and updating of the owner's project requirements and basis of design by design team members after each design review submission. You know, there's supposed to be the design review submission at every stage of that iterative design process. Don't allow them just go and create a final design and come and dump on you. And when you start making complaints like, oh, this kitchen is too small, or that stairwell is too tiny, you know, and so on and so forth. Or I need a store here, I need a small pantry there. They start saying you need to pay for extra review costs. Whereas you could have captured all of those in earlier stage design review process. Specifications of commissioning with architects and engineers, you make sure it's captured in the entire contract specification package. Participate in value engineering management reviews and make recommendations to resolve potential O&M problems. So whenever you see things in the drawings during that design review, if you see any potential operations and maintenance problems, pick them up. I've seen designs where drain pipes are being designed for 90-degree bends and they are small pipes, right? I know that a few years, people flush all kinds of stuff through the drains. Sometimes a drain trap is missing and some tenants or users just ignore, and then they let all kinds of things fall into the sink and then start blocking 90-degree bends, right? So when I say, is there a way we can make this bend not 90 degrees? Let's have 45-degree bends if we have to make a bend, some kind of shallow bends that makes things that should have blocked the pipe at an angle of 90 degrees to be able to fall through and, you know, go all the way down. Can we have some chambers here or chambers there? I know we want to have a very beautiful compound, so we want to put grass all over the place, want to fill up the whole place, but I need to have 1 or 2 inspection points at this place and that place. I need to understand the kind of piping lineup we're going to use. What are the pressure of the various pipes, you know, and for this space, we need so pressure, for that space, we need so pressure, and what kind of piping will give us those kind of pressure. Just being able to look at all of those. And then your testing procedures, the write-up for testing that's produced by Conceptual, review those, and all the commissioning documentation, you review those. The whole idea here is you want to ensure that you have operational readiness in place. All of these things, being involved and, you know, talking all of this is just to ensure that the facility is seamlessly handed over, can be operated and maintained at the least cost and with the least complications. During the construction stage, ensure that the quality assurance and commissioning activities are carried out in a logical, sequential, and efficient manner. Work with the main contractor to incorporate commissioning activities into the master schedule. Revise as necessary the construction phase commissioning plan developed during design, including scope and schedule. Plan and conduct quality assurance and commissioning meetings as needed and distribute minutes. Perform site visits and inspections to observe system construction and installation. Attend selected planning and job site meetings to obtain information on construction progress. Review construction meeting minutes for revisions, substitutions relating to the commissioning process. Be involved in commissioning tasks, including operations and maintenance documentation, contractor mobilization, and closeout procedures for each project deliverable. Work with design and construction teams to review submittals applicable to systems being commissioned for compliance with commissioning needs, and review change orders for impact on maintainability and client objectives. What you're basically doing here is ensure that the construction is, they are building what was designed, and if there are going to be changes, they are documented. Also ensure that the quality of what was specified is what is being built. So you are like the owner's representative throughout this project. You're not the expert, you're just asking some questions here and there, just to ensure that everybody remembers to do what is right, not to bury something that you come to have to deal with later. Commissioning records, you compile these also during the construction stage, all the operations and maintenance manuals, testing and commissioning manuals, handover manuals. Just make sure the engineers are able to provide this in a format that you can use. So it's preferable that as an FM, you share certain parameters you want. For example, your asset register. If asset register are coming out of the project, it should include the specification, the capacity, for example, the model and make, if it's an MEP equipment, and so on and so forth. So you can have the base information that goes into your asset register. Policy checks for commissioning activities, witness and include documentation in the commissioning record of all major construction or installation that's critical to long-term serviceability and sustainability of the development. Document construction checklist completion by reviewing completed construction checklists. Coordinate and witness functional testing for all commissioned systems and assemblies by the main contractor. Maintain a master issues log and report all issues as they occur. Provide written progress reports and test results with recommended actions. Review equipment warranties to ensure that client responsibilities are clearly defined. Facilitate and oversee the training of clients' operating personnel. Review the preparation of the O&M manuals for commercial equipment and building components. What you're basically doing here is, getting involved just to check. You're not the one doing the construction. You're not the one correcting what they are doing. You're just making sure that what they promised they will do. And something that needs to happen at this stage, at this construction stage too, is before we even get through design to construction, at the planning stage, when they are thinking about what kind of contract to put in place for the construction, whether it's going to be a master contract for one general contractor, whether it's going to be small contracts for different subcontractors with the owner acting as the general contractor, the FM needs to ensure that quality assurance, commissioning, quality control activities are built into the contract, because sometimes you miss out on those critical items and you just begin to expect the contractor to start using his own time, his labor and money to be doing quality assurance for you. No, that's not how it's done. You either create an FM consultant who is a commissioning consultant to help you run through this commissioning process, this quality assurance process, or you incorporate them into the contract so that the contractor is paid for a line item that includes as-built drawings. As-built drawing means going to draw again what you have built, right? So that's a line item that needs to be paid for. At the post-construction stage, you're preparing the client to supervising required actions during defect liability. All of those things that were picked up as deficiency are corrected. Do the final testing and final commissioning reports. Assist with pre-qualification and selection of FM service provider. Whether you're going to have an integrated FM company who manages everything, or you're going to have service providers for different services. Assist with the pre-qualification process. Even if you are going to use original equipment manufacturer representatives that were part of the construction, still pre-qualify them for O&M if they are going to do O&M, because construction is very different from maintenance, and many people miss this point. And then develop the FM service specifications. It's very important that we develop the FM service specifications. Specification for the various services. So you list out all the services that need to be delivered according to the users and their requirements that you have envisaged from the planning stage. And then for each specification, every service line item, we develop a set of scope of work, specific conditions, specifications of the service, of quality measures, and so on and so forth. And you develop all of it because they will go into the contracts that you sign with the service provider. Identify and solve problems or concerns with operating the building as originally intended. Monitor warranty period compliance and review with facility staff the current building operation and the condition of outstanding issues related to the initial and continuous commissioning. And then make suggestions for improvements and for recording these changes in the O&M manuals. Remember, you got O&M manuals from the manufacturing process. What are these O&M manuals? They are documentation that describe how built equipment, facilities, building components, or infrastructure are going to be operated and maintained. So they are actually like guidelines for FM to work with them. Identify areas that may come under warranty under the original construction contract. Assist facility staff in developing reports and documents and requests for services to remedy outstanding problems. Provide effective operations and maintenance of the building, and provide effective occupant services. When the occupants begin to come in, you need to already have a design of occupant services, starting with a survey of what their needs are and the service level developed based on what their requirements are before you even begin to talk to contractors about service contracts to provide services to match the spaces that you are taking over. Some of the basic things you should already have in place as information that you need. We call this your basics. First of all, you understand the organization. What are the business drivers, constraints, planned business changes? What are the targets of the organization itself? Then you now say, what is the facility I'm going to be managing? How big? How spread out are they? How many people work in them? What are the occupants like? You go to the services that they need. You understand what the specifications of those services are, the scope of work. The current team that's managing those services. What changes will be required? What are the specific requirements of management? You go into the cost, historical cost of what's been happening in the organization, because you'll be expected to manage a new facility you are taking over using the same average cost or better, cheaper cost compared to the buildings the facility the owner used to have. But if you don't have those data so you can match service or specification with those costs, you may end up being with a backlash against the cost you are trying to bring in. Understand key performance indicators, customer satisfaction index, requirements of the customers and the owners, other compliance issues that you need to take over. These are part of things you need to take over, become abreast with. So when you take over a new facility, it's not about jumping straight to operations and maintenance. You need to understand the facilities that you're managing. And some of the things that needs to be in place, lots of documentation. Vendors who worked on it, who have been part of the process, the kind of contracts that they had, the information on the landlord, if it's leased facilities, what kind of leases, utility bills, historical data for that, accounting requirements, IT requirements. This is just an extension of the list I just showed you, right? The building permits, the equipment list, maintenance records of what's been done in that facility before you took over, all the critical items like emergency response program, if there is one, if there is none, how do you put one in place, and so on and so forth. These are things that you should have in place. I call them your basics. You need to have this basic information on ground before you start saying I am managing a facility. You may not have all of them 100%, but it's important that you start developing them when you start taking over. So even if you didn't get them originally and, oh, well, they didn't give us as good drawings, they didn't give us, that doesn't mean that you just throw your hands in the air and give up. You start developing them, start seeking information, start securing data. Sometimes you have to start the process of reverse engineering the whole process with management approval. What that means is that you start creating drawings, start getting people to come and count and create schedules for you, so you can get some semblance of data that you can use to run the facility. All right. If you don't have operational readiness in place, you will have all kinds of deliverables given to you, documents from all consultants and designers in different formats, that you cannot really relate with, not properly organized, incomplete. Sometimes the information is really provided to create more confusion because you'll be seeing something on ground and the document will be saying something different, right? And then the formats they even bring the documents in might not even allow you to do easy manipulations of those documents. For example, gathering asset data from inside documents submitted by different consultants can be quite problematic if they are not submitted in the same format, or even provided in a editable format that you can copy and paste into your own asset register. Imagine getting all of those asset information inside drawings that are PDF. You have to basically scrape information from those PDFs into a spreadsheet you create. You'll be unable to properly set up a plant maintenance program because you don't have enough data. You don't have a plant maintenance manuals to do that. You have to do a lot of research to come up with a maintenance program. Unable to find essential documentation. Very key documentation will be missing. Sometimes regulatory authorities will come and slam you some levies of fines for non-compliance, and these things are supposed to have been handed over to you from the construction. unstructured handover of equipment and facilities, and you can be in the experiencing major time waster. But if you do operational readiness, you have organized documentation in format that you want, that you can use. They will not only be orderly but organized, and you can easily find the documentation, the data you need out of the documents delivered. So we'll talk about these documents in 3 categories: the operational and maintenance documents, testing and commissioning documents, and the handover document. And we're going to look at what each set of documents expects to have in place. You may not necessarily have all of them, but you need to have, some critically to help you serve your users when you take over the facility completely. When you have operational readiness in place, you are contributing to saving a large chunk of the O&M costs, right? O&M cost is the major cost of most facilities that you see. First, it runs through a life cycle period, lifetime of the facility. If you get it right during the planning, design, construction with operational readiness, that O&M cost will be manageable, as it were, will be optimized, will be reduced to the barest minimum, because most of the concerns you will be having as an airframe, things that will come to cost you money to solve problems later, would have been considered and taken care of in that 10%. So imagine increasing 10% to 15%, and still sounds like, wow, we've gone 50% above our construction project, right? But that extra 5%, that 50% so-called construction, is only 5% of life cycle costs. Imagine this 62% of operations and maintenance costs is able to be slashed by a quarter, right? Or by 20%. That on its own would have saved the organization a huge chunk. So that 5% that was saved, that was spent extra in original design and construction, which is like, so large in perception. When put in the scale of operations and maintenance costs, it pales. It becomes so meager that it's easy to sell. And the whole process of getting it right, getting the right operations and maintenance program in place is system thinking. You have to think about, the output you want to get. No matter how hard you work on the output in your throughput, if you don't have the right input, you won't be able to do it well. So in essence, FMs cannot deliver on proper FM operations and maintenance without having a proper operational readiness that comes in through that process of delivery of the facility. This is just another breakdown of that process of running the facility from construction to operation, repair, maintenance, upgrade, and retire that we talked about at the beginning. So operational readiness program protects capital investments in companies, plant equipment, and buildings, because the preventive maintenance program is available at handover. It ensures that equipment lasts for its design life, one of the factors which ensures a reliable income stream for the company from revenue earning facility. If you put it in place, you definitely have the right output. When should you launch operational readiness? At design phase or in the early stage of construction? Definitely at or before design phase. Operational readiness is not something you do during construction, because if you miss operational readiness talk during design, you definitely can't get it right, because once designers have designed and construction is starting, if you have to make substantial change, you might even get all the way back to permitting licenses with the regulatory authorities before you can make such changes. So it's better you are developing that operational readiness program or having that input early enough before design is finalized. So some documentations, schedule of assets, operating manuals, contact information of manufacturers, safety procedures, index of drawings and plans, maintenance schedule, testing equipment and tools, and then the equipment that are installed or the assets that are installed, their specification, interface, part list, recommended spare parts. These are the things that you need as a facility manager to operate and maintain those facilities. And then documentations that come out of the testing and commissioning program. All of these as build drawings, as build bills of quantities, snag lists. GIS coordinates talks about the global geographic information system. That's the global positioning system that identifies the location of every asset in your portfolio, in your site geographically. Details of vendors, guarantees and warranties in place, details of those guarantees, manufacturer recommendation, legal documentation, design modification information. And then you have the handover documentation that includes a definition of when the project is acceptable to be termed completed, regulatory documents, all those permits, when they got lights in, when they got permits for the different installations like sewage system, like the diesel tanks, warranty documents, all the defects that were fixed back and forth during that process, your training record, how the O&M staff that you're bringing in are trained by the construction and commissioning team, the O&M manual itself has build drawings and test results that were done during the testing phase. So this is basically the set of documentation you should have in place among those. So if you were to take what are the most critical, the ones that you should at least as a minimum have in place, right? You need to have as-built drawings, at least as-built drawings. You need to have regulatory documents and warranty documents as a minimum. You need to have operations and maintenance manual. Now, this is something that you can develop because sometimes the construction and engineering crews may not want to worry themselves about that. From here, I would say look at the manufacturer recommendation, because when you're developing your maintenance program, you need to know what manufacturer recommendations are, and then the vendors, the vendors who worked in it, just having their details so you can have a reference point to call back when the need arises. Of course, the need will always arise, and if you don't have those details, you may struggle, and you may have to do all kinds of research again. From this one, you need to have the asset register. You need to have, safety procedures, yes. If you don't have safety procedures, you might make some mistakes. You can research the process again and create your own safety procedures. The maintenance schedule for the one that requires PPM, and then importantly, your parts list. You know what are the main components of every equipment that's installed for you, and the recommended spare parts you should have installed. When you take over and start running them, not when something breaks, you start hearing for the first time it's a particular name of a component. If your technicians and the contractors even know that you're that ignorant, they may even make up names of things to make money out of you. So let's be very. Yes.
Hello, sir.
Yes.
This is Maria. I want to ask, in giving input into planning,
yes,
is there any sign off so that whatever inputs one has given is not just thrown away at a point and somebody will come up and say, yeah. So is there a process for signing off on inputs?
So usually inputs are collated and reflected in, for example, the design, right? So when design starts coming out, you will check the design to see if the input has been incorporated. Contract documents, the bill of quantities written by the quantity surveyor. So it now becomes another responsibility to check through relevant outputs from those the inputs were given. You know, the inputs are added so that this design and engineers, engineering team will use those inputs in their decision making while creating the documents that will come out of their own process. So it's now for you when you receive it to quickly check to be sure that those things that were given as inputs were incorporated. If they're not incorporated, you mention it again, or you send emails or correspondence that serves as a record of those inputs. Because if you've made an input during a meeting and the minute of the meeting comes out and that input was not captured in that minute, it's not been recorded. So you may want to correct that. Let whoever is taking the minute capture the input. Then when those deliverables of documentation start coming up, you check to be sure that those inputs have been incorporated. If they've not been incorporated, you can send emails in the back and forth correspondence through that development process to ensure that they are documented appropriately. And if they are not, at least you have a record that you have, you know, followed up to ensure the inputs were captured. Is that okay, Bumi?
Yes, sir. Thank you, sir.
Thank you. Hafiz. Hafiz, go ahead.
Good evening, sir.
Good evening.
My question is very simple, sir. During this course, from the beginning of this course, I've been hearing has built drawing, has built drawing, has built drawing. I know that has built drawing is will be termed to what exactly is on ground after a construction has been done.
Yes.
But my question is, how do you come up with, who does their as built drawing? Number one. Number two is that when we say we have as built drawing, are we not contravening laws? Let me simplify it now. That's the first question: is how do we come up with as built drawing and who does it? The second one is this: I know in Nigeria, before you start construction, you have to get approvals, different level of approvals, building, planning, and all these things from the government. Now, if you come up with an as-built done, is it not contradicting what has been approved by authorities, regulatory authorities? That's the second question.
Okay. First, as-built drawing is produced as an output from the construction phase. So the general contractor is responsible for that. Once it's finished building, he needs to do a measured drawing of what the actual situation is, right? Now, that measured drawing can come out to be exactly as designed. So as-built drawing does not mean it has to be different from what was intended. It only means this is what was built. And what was built could be exactly what was designed and approved. Now, there are so many changes during construction. Take, for example, where you wanted to do a louvered window, you now change it to sliding of casement windows for a particular space in that design. Now, for that little change, you may not need to go back and get a whole approval or revision of your designs again from the approving authority, right? But you need to capture that change in the as-built drawing, because if the drawing that I'm using to maintain says it is a louvered window, and then I have on ground casement window, by the time I start trying to buy hinges and handles to fix casement windows, I might be audited and found to be trying to create a fraud in the system. Why are you trying to buy casement window hinges and accessories when you don't have casement windows in the building, right? So the changes can be subtle. It can be as simple as there was intention to put emulsion on an internal space. The owner comes and says, look, why not just change it to screening and put vinyl paint for me there, right? When that happens, the as-built drawings need to reflect that. That's not what was in design drawings. so many changes. Even something as simple as the drain piping for an AC drain can be different. You know, it's supposed to drain to the right. We found a reason why it shouldn't drain to the right during construction, and we drained it to the left. It's all buried in the wall. It should be captured in an as-built drawing. So the whole idea of as-built drawing is exactly what was built should be there. So the contractor should develop it and make sure that it is there. But you as an FM or the owner should provide a line item in the contract to ensure that there is money to take care of that activity, because it will take time and resources to deliver, and cost is attached. And if you just assume that out of their goodwill, they will do as-built drawings for you, forget it. Many of them will just take the design drawings and relabel it and send to you as the best they can do. Now, if they fail to give you as-built drawings, you have to now reverse engineer the process of creating it by actually measuring. In fact, my FM career started out developing as-built drawing for facility managers. I'll go with colleagues, we'll measure, we will draw and sketch out and do what we call material schedule, you know, for old facilities. We'll do material schedule, we'll come up with the tiling area, quantities for tiling, quantities for painting, different types of painting, windows, doors, architectural features. We even do quantities for plumbing. We'll do estimation of piping lines, types of pipes that runs through those lines. You know, of course, you cannot be that detailed without doing some level of obstructive inspections to go in and see what kind of pipes, pressure gauges, and so on, so you can specify them correctly inside a drawing. You can create that even if you have it from the onset. It costs money, right? So that's the thing, but you need it. Instead of calling a painter or a painting company to come and look at your building and give you quotes for painting, when somebody will come with, oh, I'll buy 5 drums, the other will come and say it's 4,000 square meters, I'll paint per square meter. You'll end up looking at apples versus orange that you cannot compare. Instead, know how many square meters of emulsion spaces you have, square meters of granite finish, square meters of aluminum cladding, because you have those material schedule in your from the drawings that you have, and you can put them in bits of quantities and get quotes that you can compare rates easily.
Okay, sir. Thank you very much, sir.
All right. All right, thanks, guys. Have a good evening. I'll see you again on Wednesday. Bye-bye.
Thank you, sir. God bless you.
All right, sir. Thank you.
Thank you.